More than 10 kilometers beneath the surface of the Pacific Ocean, sunlight simply stops existing. No blue, no warmth, no seasons. Cold and a darkness so complete it feels permanent. Down here, the weight of the ocean above is almost unimaginable. Every square inch is crushed by forces powerful enough to bend steel, shatter glass, and collapse machines built by the best engineers on Earth. For a long time, this place was thought to be utterly lifeless, a depth where biology itself should fail. Cells should rupture. Proteins should unravel. Life, by all known rules, should not function here, and yet, it does. In the mid-20th century, at a depth no human had ever reached before, explorers reported something moving slowly across the seafloor. Not debris, not sediment, but a living organism, calmly existing in an environment that was never supposed to support life. Since then, we've only seen this world in fragments. A few seconds of grainy footage, brief flashes caught in artificial light. Creatures hauled to the surface, crushed, distorted, barely recognizable. Most of the time, the deep ocean reveals itself just long enough to remind us how little we truly know. Even today, this abyss remains one of Earth's least explored frontiers. We have mapped distant planets in greater detail than the deepest regions of our own ocean. And hidden within that darkness lies the most extreme environment on Earth, a place carved by titanic geological forces, a place ruled entirely by pressure, a place where life survives by rewriting the rules of biology. This is the Mariana Trench. And tonight, we descend into its depths, past the limits of human endurance, past the reach of conventional technology, into a world that challenges everything we believe about life on Earth. And you are watching this journey with Beyond the Extreme. Stretching across the western Pacific, the Mariana Trench forms a long, curved depression in the ocean floor. It begins far south of Japan and arcs toward the Philippines, reaching depths greater than anywhere else on the planet. At its lowest point, the Challenger Deep plunges to nearly 11 kilometers below sea level. If Mount Everest were placed inside it, the summit would still lie more than 2 kilometers beneath the surface. For most of human history, the existence of such depths was unknown. The oceans were vast, unmeasured, and deeply feared. Sailors filled the gaps in their knowledge with legends of monstrous creatures and bottomless abysses. It was not until the late 19th century that humanity began to measure the ocean in any meaningful way. In the 1870s, a British Royal Navy ship named HMS Challenger set out on an ambitious mission. Its goal was nothing less than the first global survey of the world's oceans. For nearly 4 years, the crew crossed every major ocean basin, lowering heavy lead weights attached to long ropes to measure depth. Each sounding was slow, exhausting work, carried out by hand in blistering tropical heat and bitter polar cold. Most of the measurements told the same story. A broad, featureless plain of mud and silt, typically 3 to 4 kilometers below the surface. But in the western Pacific, thousands of kilometers from land, the crew took a sounding that refused to end. The rope passed 1 kilometer, then 2, then 3. It kept going. More rope was added. Still, the weight did not touch bottom. One can imagine the unease on deck as the line continued to disappear into the dark water below the ship's thin wooden hull. At sea, danger was already a constant companion. Storms could tear ships apart without warning. Superstitions filled the unknown with terrifying possibilities. And now, beneath them, lay a depth that seemed endless. Eventually, the weight struck the seafloor more than 8 kilometers down. It was the deepest depth ever recorded at the time. On later charts, this location would be named Challenger Deep, in honor of the ship that first hinted at the true scale of the abyss below. Decades later, with the development of sonar and more advanced instruments, scientists returned to the region. What they found was even more astonishing. The original measurement had barely scratched the edges. The deepest part of the trench plunged far deeper than anyone had imagined. Understanding how such a feature exists requires looking beneath the ocean itself. The surface of our planet may appear solid and unchanging, but it is anything but. Earth's outer shell is broken into enormous tectonic plates that drift slowly atop the hot, semi-molten mantle below. These plates move only a few centimeters each year, but over millions of years they reshape the planet. Where plates pull apart, new ocean floor is created as molten rock rises and solidifies. But where plates collide, something very different happens. The heavier plate bends downward and sinks beneath the lighter one, disappearing back into the mantle. This process is known as subduction, and it is responsible for the deepest trenches on Earth. The Mariana Trench exists because the Pacific Plate, one of the oldest and densest pieces of oceanic crust on the planet, is being forced beneath the smaller Philippine Plate. As it sinks, it drags the seafloor down with it, bending the crust into a long, narrow trench. This slow, relentless motion has been shaping the region for tens of millions of years. The same process occurs all around the Pacific Ocean, forming a vast horseshoe-shaped zone of instability known as the Ring of Fire. This region contains most of the world's active volcanoes and is responsible for the majority of Earth's earthquakes. The Mariana Trench is one of its deepest scars, a visible mark of immense forces operating far below the surface. Reaching such depths presents challenges unlike anything encountered on land. The greatest of these is pressure. Water is heavy, and with every meter of depth, more weight builds above you. By the time you reach the bottom of the Mariana Trench, the pressure exceeds 1,000 times that at sea level. This force is powerful enough to crush most machines instantly. Even modern military submarines operate at depths of only a few hundred meters. Some of the deepest diving designs may reach around 1,500 meters. But beyond that, the risk of catastrophic failure becomes too great. The Challenger Deep lies far beyond these limits. Despite this, in 1960, two men attempted the descent. Don Walsh, a U.S. Navy officer, and Jacques Picard, a Swiss oceanographer, descended into the trench aboard the bathyscaphe Trieste. Their vessel consisted of a thick steel sphere suspended beneath a buoyant float filled with gasoline. It was cramped, slow, and pushed to the edge of its design limits. The descent took nearly 5 hours. At around 9 kilometers deep, a loud cracking sound echoed through the cabin as one of the outer window panes fractured under pressure. The inner pressure sphere held, and they continued downward. When the Trieste finally reached the seafloor, the sediment was stirred into a thick cloud. Visibility was poor, and the surrounding world appeared ghostly and alien. But then, in the light, something moved. Life had reached the deepest place on Earth. As the descent continues beyond the familiar zones of the ocean, the environment becomes increasingly unforgiving. Sunlight has long disappeared. Temperatures hover just above freezing, and pressure increases to levels that challenge the very structure of living tissue. In this darkness, life no longer depends on energy from the surface. Instead, survival is shaped by scarcity, efficiency, and extreme adaptation. Food reaching these depths is rare. Most organic material produced at the surface is consumed long before it can sink this far. What little remains drifts downward as fine particles, a slow and constant fall known as marine snow. For many deep-sea organisms, this sparse snowfall is the only source of nourishment. Every movement, every metabolic process must conserve energy in an environment where waste means death. Below 6,000 meters, the ocean enters the Hadal Zone, a region named after the underworld. Here, pressure exceeds anything found elsewhere on Earth's surface environments. For decades, scientists believed that complex life could not exist here. The forces involved were simply too extreme. But exploration has proven otherwise. Cameras lowered into the Mariana Trench have revealed swarms of amphipods gathering around bait within minutes. These small, shrimp-like creatures dominate the Hoddle ecosystem, scavenging whatever organic matter reaches the seafloor. Their bodies are flexible and resilient, allowing them to withstand pressure that would crush rigid structures. Even more surprising are the fish found at these depths. Certain species of snailfish have been observed living deeper than any other known fish. Their bodies are soft and gelatinous, with reduced bone density and specialized molecules that stabilize proteins under immense pressure. These adaptations allow them to function normally in conditions that would destroy most vertebrates. At the microscopic level, life becomes even more unusual. In the deepest parts of the trench, entire ecosystems are supported by chemosynthesis rather than sunlight. Microorganisms feed on chemicals such as methane and hydrogen sulfide released from the Earth's crust. This process provides energy in complete darkness, forming the base of a food web entirely independent of the sun. Among the most remarkable inhabitants of the trench are xenophyophores. These single-celled organisms can grow to astonishing sizes, forming complex structures from sediment particles. They thrive in high-pressure environments and play an important role in shaping the seafloor ecosystem by providing habitat for other organisms and influencing nutrient cycles. Despite these discoveries, our exploration of the Mariana Trench remains extremely limited. Only a small number of vehicles have ever reached the Challenger Deep, and even fewer have done so repeatedly. Many missions last only a few hours, offering brief glimpses into a world that operates on completely different rules. The difficulty of exploration means that much of this environment remains undocumented. Species may exist that have never been observed. Entire ecosystems may function unseen, shaped by processes we have yet to understand. The deep ocean does not reveal itself easily, and every discovery raises new questions. What makes the Mariana Trench so important is not just its depth, but what it represents. It challenges our assumptions about where life can exist and how it adapts to extreme conditions. The organisms found here survive without sunlight, under crushing pressure, and with minimal energy. In doing so, they expand the known boundaries of biology. These discoveries also reshape how we think about life beyond Earth. If organisms can thrive in the deepest, darkest parts of our oceans, it becomes easier to imagine life existing beneath the icy shells of distant moons or in subsurface oceans far from any star. The Mariana Trench is not a lifeless void. It is a living system, shaped by geology, chemistry, and evolution over millions of years. It is one of the last great unknowns on our planet, hidden beneath kilometers of water, beyond the reach of everyday observation. As technology advances, we will continue to push deeper, to stay longer, and to see more clearly into this darkness. Each descent brings us closer to understanding not only the ocean, but the limits of life itself. And as we reach the end of this journey into Earth's deepest abyss, one truth becomes clear. The most extreme environments on our planet are not empty. They are alive, complex, and full of stories waiting to be uncovered. The Mariana Trench stands as a reminder that Earth still holds mysteries as profound as anything in space. And as long as we continue to explore, the darkness will keep revealing surprises, because this is Beyond the Extreme.